Welcome to PM Ready, your guide to becoming PMP certified. This is the lesson about project constraints, Part 2. In order to help you remember and visualize the need for balance between these project constraints, it may help to picture a scale in which scope and quality are on one side of this balance and cost, schedule, resources, and risk are on the other. Notice in this visual, they sum up to be equal, and so the scale is balanced. But any change made to an element on one side is going to require a change. So if quality were increased, in other words, there was a need to increase the level of quality on a project, that's going to cause the scale to tip to one side. You're either going to have to reduce your scope to keep the balance, or you're going to have to increase something on the right-hand side to compensate for it. Greater cost, greater schedule, more resources, or greater risk. Now, suppose you need to add more scope to your project, and you decide to accommodate this by asking your team members to put in some overtime. This is because you don't want to increase your cost, and you don't want it to take any longer. Let's assume for the moment that these are salaried employees and that asking them to put in a little bit of overtime won't actually cost you any more salary. You could do this and keep cost and schedule the same and effectively increase the amount of resources on your project. This would help maintain the balance. However, it's important to keep in mind that risk is often affected when you make changes like this. In this case, you run risks around or regarding resource availability. The more you expect of resources in a given day, the more likely it is that their availability may not be what you've scheduled. You're also putting more pressure on your team members. So you're increasing the chance of burnout, of people becoming disaffected, or people losing motivation, or people getting sick and needing some time off. These are all increased risks that you need to consider as you make these kinds of changes to your project. Now let's consider the case of scope creep. Scope creep is scope that has been added to a project but not properly managed or approved. This is uncontrolled scope. So suppose, for example, you've been asked to add a few little features and you think that adding this shouldn't have a big effect on cost and schedule. And you hope that you can just slip these in, or you're under pressure to add these features without increasing cost or schedule. So if this change hasn't gone through appropriate change control, you haven't adequately considered the impact of these changes, this is called scope creep. This hope that you can get it done within the existing budget and timeline dramatically increases the risk on the project, specifically the risk that it is going to cost more and take longer. You should never allow scope creep on your project. All proposed changes to scope need to go through the proper change management process in order to consider all of its implications. Let's suppose a project manager decides to let some scope creep into their project, but is very concerned about making sure that it doesn't cost more or take longer. And so to try and compensate for that and prevent that from happening, the project manager runs around putting a lot of pressure on the team members to get the work done in the same amount of time and for the same cost. The result is going to be sloppy work. It's going to be lower quality. And that's how you'll get your balance. Like it or not, the quality is going to go down in order to meet the original budget and schedule. This reduction in quality might not show up right away. This could be a very deceptive change to the project. you may not notice the quality problems until the project is done and you're dealing with an increase in warranty issues with the products. When it comes to software development, you're more likely to end up with code that is much less maintainable and very difficult to upgrade in the future. Usually the best approach to an increased scope on a project is to increase the cost and schedule appropriately, adding the additional time and money needed so that the resources on the project can maintain a sustainable pace so that quality doesn't suffer and risk isn't increased, at least not by much. Now let's move on to reducing the amount of time it takes to complete a project. What are some of our options? One is that we could crash the schedule, which simply means we add more resources to the schedule in hopes of getting it done sooner. Another is to fast track the schedule, which is when we decide to do tasks in parallel or to overlap tasks that we wouldn't have normally overlapped. That can help us to reduce our schedule. Another obvious one is that we could just simply reduce the scope of work to be done. Another is we could reduce the quality. Or we could increase the risk. One way we might increase risk is to remove some of the contingency buffers of time that we have in our schedule. These are just a few of the ways that you might reduce the amount of time on your project. Not all of them are good ideas. A good way to get the project done quicker is to reduce the scope. This will naturally reduce the amount of time and money that it takes to complete the project. In addition, you might even shift some of the cost savings and spend a little bit more money in order to further reduce the schedule by adding more or different resources to the project. Another way to get a project done quicker is to lower the quality. This is not often very desirable, but sometimes it may be. For example, suppose you're working in a new startup and developing a new software application, and you need cash sooner. And so you decide you want to release sooner. So one of the things you could do is to go ahead and let the code be less maintainable. You might even decide to plan on the first release of this code to be a throwaway code, and that after doing this first version, you're going to take everything that you learned from it and learn from the market and apply that to building a second version from the ground up. So you don't need to worry about the code being very maintainable. This is a rather dangerous trade-off to make because all too often companies get caught in this problem of needing to make some minor changes to the first version before the second version is ready, and it can end up costing you more in the long run than you anticipate. However, it's not a bad strategy if you know what you're in for. Another way in which you might get a product out quicker is if you change your target audience. So let's suppose you're developing a product for mass production and you decide you want to get it done sooner. You could switch from trying to be the top quality product to instead being just the best value product, which would be a little bit of a step down in quality, but still a good option considering your need to get out sooner if the market is open to having a best value product. Or you might, if you've been planning to do a best value product, you might decide to lower the quality and go for the lowest price position in the market. Suppose that in order to finish sooner, you decide to crash the schedule by adding more resources in hopes of getting it done sooner, and this will cost you a little bit more in the short run. So what would this approach look like in our scale model? Crashing the schedule by increasing the resources. As you can see on the right-hand side, the resources is a little bit larger and schedule is a little bit smaller. Also notice that cost is a little bit larger simply because of this mythical man-month issue that as you add more resources, it's going to cost just a little bit more. Suppose instead that you decide to speed things up by fast-tracking the schedule, which is when we overlap tasks that we hadn't originally planned to overlap. This is a good alternative to crashing. You use the same resources you had planned to use, but you do run some risk that by overlapping these tasks that a delay in one task could affect the other, or that there are things that really should have been done in a certain order that you're now trying to do all at once. And this is what a fast-tracking approach looks like using the scales. The cost and resources are the same. We've reduced the schedule, but we've purchased that at the cost of increased risk. Now let's suppose that you decide to reduce the schedule by simply operating some machinery at a faster pace. This way you keep your costs the same and your resources the same, and you're able to reduce your schedule. It may seem that all is well. However, your risk is increased. You have increased risk of breakdowns and of safety issues. This kind of risk is often hidden, but really should be acknowledged as part of reviewing a proposed change request. Now, this would be a more accurate representation of this kind of situation where you're increasing risk in a way that's hidden. Most people may not see it, but it's tipping the scales. It may or may not affect the cost, schedule, and resources and other factors of the project, but it well may. And even though most stakeholders may not see it or may not want to see it, as the project manager, you still have an obligation and responsibility to try your best to communicate this increased risk to the key stakeholders. Suppose you need to increase the level of quality on your project. Higher quality? Well, the best response is usually to spend more time and money. This might also require more resources on the project. This could involve more expensive materials, more time to work the materials, more time to write higher quality code if it's an IT project, code that's more robust and more maintainable, and so on. Another good way to increase the quality on your project is to reduce the scope. This could involve taking more time on each task, but doing fewer tasks. You'll naturally finish fewer tasks in the given budget and schedule, so you'll need to prioritize all of these tasks and features and drop the ones that are on the bottom of your priority list. For example, you might decide that you need this IT project to result in an application that has better usability for the end users. So you spend more time on software usability design and testing during the design phase of the project, and in exchange, you defer some of the lower priority features until a later version. Now, what if you need to lower your costs? A simple, easy answer to do that is to simply reduce scope. You may have market condition changes or financing changes that require you to reduce the costs on the project. So just reduce the scope. Just as with the previous example, you'll need to prioritize your items on your scope list and focus first on the highest priority items, and then defer those that don't make it into your cost budget. This may sound pretty painful, but keep in mind the Pareto principle for software, and that is that, generally speaking, 80% of the value of a software application comes from 20% of the features. This is because that when it comes to software, 80% of your users only use 20% of the features. Realistically, reducing scope also reduces other constraints. To reduce cost, reduce scope. This will naturally result in a reduced need for resources, which in turn will result in reduced cost. Another way that you can reduce costs is to lower quality, just as we did when we were trying to reduce the amount of time it would take to complete a project. For example, you might decide to go with cheaper materials or equipment, or lower labor rates. On an IT project, that would result in code that is buggier and less stable and less maintainable. For a hardware project, that might mean choosing a server system that is less robust. For example, you might decide to go with a cold backup instead of a warm backup or a hot backup. Basically, that means that it would take longer for your backup to be up and running if there's a disaster or a failure. Or you might decide to spend less money on user interface design and end up with a system that is not as easy for the users to use. Whatever you do, try to avoid trade-offs that create bigger problems later after the project is completed, because those problems tend to be hidden and can be much higher than anticipated. For example, not maintaining your equipment properly can result in poor performance and breakdowns later on. Or going with lower quality equipment and facilities can cost you more in maintenance costs later and introduce greater safety risks. Let's review the balancing of the 6 constraints using this equation or scale model. Suppose you have a project and you need to spend less. What could you do? To keep the balance, you could reduce the scope or reduce the quality. You could also increase the risk on the project. What if you needed the project to finish sooner? Meaning the schedule needs to be reduced. You could do that by crashing or fast-tracking the schedule, which would increase cost or risk. Or you could do it much more safely by reducing scope. Or you could reduce quality. Or what if you don't have the resources that you really need to finish the project? Well, if you have enough resources to do it at a slower pace, then that could work out by extending the schedule. Or you might have to accept lower quality or try lower scope on your project. What can you do if you want to reduce the risk? Well, you could bring on higher quality resources or spend more money to manage risks. That would help to reduce risk and keep things in balance. Or you might reduce the scope by eliminating high-risk items. What if you wanted to improve the quality? Generally, that would typically cost more and may involve more resources, or it may involve fewer resources, but focusing on high-quality resources that will allow you to improve the quality on your project, but at greater cost. To summarize this lesson, remember that constraints are limiting factors, whereas assumptions are things that are assumed to be true, but may or may not be, and that the assumption log contains both the constraints and the assumptions. We spent a significant amount of time on the triple constraint, which is the combination of scope, time, and cost, which can be represented using the triangle or using this formula of scope equals time plus cost. We also discussed and practiced balancing the 6 constraints, where scope and quality equal cost, schedule, resources, and risk. The PMBOK guide contains information about assumptions and constraints on pages 28 and 542, as well as in the glossary on pages 699 and 701. PM Ready is a publication of PM Guaranteed and is based on the Project Management Institute's PMBOK guide.